All righty, let's go ahead and get started here. Thanks for joining my session around how to guarantee data SLAs with data observability. And before I get going here, I just want to let you know right away, there's lots of resources if you want to learn more about Databand in particular. I'm not going to be talking about Databand specifically today. There's lots of things like quick demos on Databand.ai. If you want to go to the demo center there. Also, Eckerson has this tech event set up where you can go to the resource section there and look at some virtual bake-offs of some of the solutions you may be introduced to today. And then, of course, if you want a demo of Databand, happy to go walk you through that. Just go to databand.ai and request demo, and we'll get in touch with you. So it looks like I've got more and more people coming in. This is great. Again, if you want to take a screenshot of this, feel free to do that. But I just want to give you some quick resources to go to if if I get boring in this presentation today, you can just say, you know what, Ryan, I'm out of here. I'm gonna go watch some videos. But real quick, a little bit about me. My name's Ryan Yackel. I've been at Databand for a while now. I think it's really important just to connect people in this virtual world of kind of who I am. So I'm one of the product evangelists and also lead marketing over here at Databand. Just got back from Gartner, as you can see on the right side over there. That was me looking like a jabroni, just trying to make sure people came by our booth. You'll see this picture today in the presentation. And I've got a wife, two kids, a dog. Her name's Daisy, the dog. She's sleeping over here, so she may jump up on me. Hopefully that won't happen today. And again, in the comments, put in there about Superman, big Superman fan. Feel free to ask me any comic book questions. I will definitely love to answer those. And then I'm a coffee addict. As I'm drinking coffee right now, I'll be taking a few sips along the way. So that's a little bit about me, and I'm really excited to talk to you today in this brief time we have together. So real quick, you've kind of been at this observability conference. I know that Kevin has done a really good job of kind of laying out the landscape around data observability, and this is a big thing that I just came back from the Gartner summit, which was it is basically one of the emerging topics in the space today, and especially in the data space, obviously, where software engineers really had this observability around their applications and services and infrastructure. Well, data engineers are kind of left behind, and they need something to really monitor their data pipelines to make sure they're delivering trustworthy data. So lots of people are really excited about this. This little girl is excited about this. She's really pumped. I was in Orlando, and maybe she wants to go to Disney World, but she's really excited about data observability. This guy over here, adults, they're also really excited about it. And also your grandma, if you don't think she's excited about it, she's definitely excited about it. And why are people so excited about this topic? Well, it's because you have data pipelines are basically feeding this modern enterprise today. Teams are having hundreds to thousands of data pipelines using things like Airflow, transforming them with things like Spark, pushing them over into lakehouses and warehouses like Snowflake and Databricks. All these things are kind of coming together to build these really cool data-driven initiatives in your organization today, which are things like business analytics, be able to make better financial decisions, data products if you're building something like a web application or mobile. Those are client-facing applications. And then also ML and AI deep learning pipelines. That's something we talked about today, how Trax Retail uses data observability in their space today. And the reason why I show this before I get into talking about the topic today is because really what comes down to is these teams, these organizations, engineering organizations, and you're probably somebody I'm talking to today about this. You have data SLAs. You have these service level agreements that you have to meet. But a lot of times in the space, you find that they've become very overwhelmed and underwater to actually meet these data SLAs. These are some things we hear from all the time, which are the fact that we can't afford to wait hours to know if a critical pipeline is down, especially if it's pushing 80 to 90% of our data through the business. Every day we have source data. Our source data is missing, or it's inaccurate, or it's incomplete. Things like we present customers inaccurate information. This leads to a lack of trust. So all these things kind of lead into, even if you have data SLAs, you've really, really, really got to make sure you have the tools in place to be able to hit them. And observability really helps with that. And it really helps specifically when you get to seeing how data observability can be used as a incident management solution in your organization today. And so the things that I'm going to be going through today are really going to be revolve around these three core areas and the metrics you want to get out of them. I'll give you some examples of this as well. these three core metrics, the three core areas you want to pull these metrics from, so that you can be alerted on something, if it's a dirty data problem, a schema change problem, a pipeline problem, all these things that are going on, be able to use these things to then take action and resolve these issues so that you can meet your data SLAs. The first one is really on process quality. So process quality is, you have lots of processes going on. I mentioned you have maybe a Spark process, you have an Airflow pipeline that's running. All these different pipelines and processes that you have, you'll be running up against DBT models and things like that. All of these things refer back to, is my process running? Is it running correctly? Is it running on time? All those things get into really around a process quality issue. If you don't know that a pipeline is even running, that's a problem. You got to be able to fix that right away. The second one is really around data quality. So data quality is something people talk about a lot, and I understand that can be very confusing at times when you're talking about data quality at rest or data quality in motion when it comes to pipelines that are moving the data. This really gets into things like null records or schema changes or unexpected values that may have popped up. This all refers to the data set that's within that pipeline. So a lot of times when we talk to customers, talk to people, that we say, hey, yeah, if your pipeline is running correctly, if it runs and it's green and it's passing, well, that doesn't mean that you're actually sending through good data. An example of this is, I used to work in software test automation, and the developers would always say things like, well, the Jenkins pipeline ran, the CI/CD process ran, and it was green. So what's the problem? I'm like, hey, well, you didn't test everything, or if just because it's green doesn't mean the end product is actually correct. So this gets into the quality that's actually being moved in the data set within that particular pipeline. And then the last one is really around lineage. So it's getting to, what are the downstream impacts of this data pipeline and data set that I have against other dependent pipelines or tasks or relationships that are there. So all this gets into how, if we have metrics that can really show us and alert us around in these three buckets here, we're going to be able to know if we're on track to meet our SLAs. And if we're not on track to meet our SLAs, we can go after it, detect it, resolve it, and get into it, right? Okay, so that was a quick intro there. And now what I'm going to do is I'm going to walk through some of the top data process and quality metrics that you need to know. And you need to know them because, again, getting back to those data SLAs, but I'm also going to give you some examples of how that could look. So if you have any more questions about this, happy to answer them. But I want to really get into, how can we report on these three buckets here to get us to where we're meeting those SLAs. Okay, first one is really around the metrics of the number of nulls in different columns that you have. This is really for data engineers, data analysts. And basically how you track it is you want to calculate the number of nulls or non-nulls, null percentages per column so that users can set alerts on those metrics. So why is this so important? Well, since a null is basically an absence of a value, you want to be aware of any nulls that pass through your data workflows, especially if it's a critical data set. So for example, downstream processes might be damaged if you have if the data used is now null instead of an actual value. You're expecting to get a piece of data within that particular column, and it's not there. The other reason why it's important too is you could have things like dropped columns. So these are values of a column that might be dropped by mistake. Data process isn't performing as expected. So this might be the entire column that may automatically disappear, which make it a lot easier for you to see, but sometimes all the values might be null. So that's another way to look at it. And the other part is around data drift. And this is if the data column may slowly be drifting into a nullness. This is like more proactive, predictive approach to understand that. So again, being able to understand that, the different nulls and what it could look like, you want to be able to understand that for the different columns. Okay, so the next one, let's go on to number 2. This is around the frequency of schema changes. Who's it for? Engineers, scientists, analysts. You want to be able to track all the changes in a schema for different data sets related to a certain job. So these schema changes are key signals around bad data quality, especially if it changes a lot. And if you have a data set that is constantly changing the frequency or constantly changing that schema, this indicates that we have a problematic data set. So in healthy situations, schemas, they're basically communicated in advance if there are going to be any changes. And they're not frequent since many of the processes will rely upon a number of columns And in their type, you have a table to be pretty stable. This is we usually expect these schemas to be the same, especially they're being consumed and pushed into different warehouses. So if you have this frequency of changes going on in this data set, that's a problem. And this could be things like column type changes, new columns, remove columns. And you got to be able to understand all this, because if a schema changes, again, just like the nulls, if the schema changes, it's going to impact something downstream. Ideally, again, we want to be able to know about these things earlier or before they're passed through, but that's a luxury that, quite honestly, is not really apparent in the data engineering team. So the next one really revolves around downstream impacts of your data set. So this is around kind of like data lineage. So for example, one of the things you always want to be able to understand is that if you have a pipeline that's failed or a data set that's corrupted, you want to be able to understand how that is going to impact something downstream, especially if it's got a read or write from a dependent pipeline. So you want to be able to track lineage of the assets that appear downstream. Definitely want to do that. And this also includes data sets and pipelines. It's not just pipeline exclusive. So, and this is, again, I can't get to how important this is, because if you just had, let's say, a few different pipelines that really didn't have a ton of downstream dependencies, and you had a break in your pipeline, then maybe that's okay. But if you have critical pipelines and data sets that are going to be used way downstream through all these different hundreds of different tasks that are reading and writing from this, that's going to be a problem. It's also an important metric for data analysts, because most of these downstream data sets are going to comply into these BI reports. And so I don't know how many times I had this conversation over at the recent conference I was at, but it was wild to have data analysts and scientists come up to us, and they basically say things like, hey, we have to manually tell our data engineering team or platform team that the data is incorrect or wrong. And I'm just like, well, I asked them, like, well, how are you alerted by that? Or how do you know about that? And they'll say things like, we're not alerted. We just have to investigate the data manually. Then we have to tell them. And I say, okay, well, does the engineering team have a way to know any downstream dependencies if, let's say, a pipeline breaks? And they just look at me blank, like, no. And so there is this disconnect between the consumers and the producers of the data. Very common problem that you're seeing, and Lineage can help you bring back that communication into one area. So that's a big thing. Understand the number of downstream impacts you have. That also, with that map, will also tell you the critical pipelines that you may have. You may have not known it was a critical pipeline or not. So very important to understand that. Okay, next one is number of pipeline failures. So this is for data engineers and also executives. Executives, because if, again, a critical pipeline has failed, that is going to literally disrupt your entire data product. So you want to be able to track the number of failed pipelines over time. You can use tools that highlight the root cause analysis and show deep dives into the tasks of the DAG. So again, really important, having ability to say, hey, I want to alert on all my critical pipelines. I want to have a critical, highly, the highest alert that I can. This is an alert I want to be known about right away. I want to be woken up at 3 o'clock in the morning. I've got 2 little girls. They wake me up all the time. They're getting better. They're 6 and 5 now, but they're getting better. But at times, I'd have to wake up at 2 o'clock in the morning, and sometimes it's it's not a big deal. They had a quick little issue that maybe they had to go to the bathroom, so they got frustrated and they went to the bathroom, and then they went back to sleep. Right? They would wake up and whine and do a little bit. That's not a big deal. But if I hear a big thump in the night and somebody starts screaming and crying, I know that's a critical notification for me to wake up, because somebody's pretty much fallen off the bed. And that's a big dramatic experience for a little girl. So I have to go in there and help them out, and hopefully nothing's bad happened to them. Hopefully they're okay. But that's an example of where, hey, even from a human perspective, I don't want to be woken up every single time by my little girls if they're just having, if they're just waking up and they're uncomfortable. But if they get hurt, I want to know about that right away, because that impacts me as a father. So being able to track these failed impacts or these failed pipelines continuously, that really gets back to being able to not only notify you when it's failed, but then with the root cause analysis perspective, then you can go, hey, how can we fix these and get these a lot better? We had a customer that before Databand, around 60% of their pipelines had at least one data issue. When Databand came in and we were able to do some of these alerting capabilities and designate critical pipelines and non-critical pipelines, all their critical pipelines they had no issues with, and they got down to less than 1% of their pipelines actually had a data issue. So great way to utilize and track the number of failed pipelines that you're seeing along the way. Okay, next one is pipeline duration, which again is different than failed pipeline. So when you're tracking the pipeline duration, what you're doing is you're wanting to track. You can track this through things like an Airflow syncer, which can report up to the total duration of your DAG, or you could use things like an SDK to kind of track this and get into it. But why is this so important? Well, pipelines are if they run just one time and they run for an hour, that's like your first run. But if you run them over time, you'll see after the past 50 runs, 100 runs, 1,000 runs, you'll see that you'll basically see like where is the threshold of this pipeline running. So maybe it runs between an hour and an hour and a half, or 5 to 10 minutes. Like, okay, that's an acceptable time frame, right? Well, if you see spikes from the average of 1 to 2 hours goes from 1 to 8 hours, or 1 to 24 hours, or 5 minutes to 75 minutes. Those are huge jumps in the duration of the pipeline. That is telling us that something is wrong there. So you can use anomaly detection to basically create a baseline of how your pipeline should operate. And then when you see these extreme deviations from that pipeline, you know something's wrong. Something's hung. Maybe a external a data source has corrupted it somehow. Maybe there's a configuration issue that's going on. So the duration of the pipelines help us to. It's an indicator that something is possibly wrong. And again, it gets back to the downstream issues of if this data is arriving late when they're expecting it to get there at a certain time and a certain day, we're not meeting our data SLAs. So being able to monitor the pipeline duration and be able to know right away if it's going to be an issue or not, you can go in and investigate it and fix it. So that's where you want to use the pipeline duration. I was talking to somebody the other day too, and that was one of the things they brought up, which was that they had these expected times when their data is going to hit their BI reports. And if it doesn't, there must have been a pipeline duration problem that was impacting it not to actually get to its final destination in the correct time. All right, we'll see here. What do we got for the next one? We're on 6. Yep. Okay, so 6. This gets into missing data operations. So how you want to track this is you want to look at all the operations that are related to a particular data set. And a data operation is usually a combination of a task in a specific pipeline that's going to read or write to a table. So if you have pipelines, you have a pipeline, but then within that you have multiple data sets, and then within those data sets you have different tasks. And those tasks, maybe those operations rather, may be doing things like reading and writing different tables or interacting with different pipelines. And so the reason why this is so important is because if a certain data pipeline is missing, then a chain of issues to your data stack is going to be triggered. This can cause pipelines to fail. This can have a problem with schema changes, delay problems. So a few examples that we talk to people a lot is that data analysts who's using data for analysis, if this operation wasn't kicked off, they don't get that. ML models are being used by data scientists and data engineers that are a part of the data. So those downstream consumers of the data, they could be affected by this if these missing operations aren't fired. And this is just an example real quick of how you can tie in alerts to things like Slack or PagerDuty, things like that. So that's a really, really cool way to be notified of any missing data operations that are going on. The next one is around the record count of a run. So this one's kind of simple, but let me explain why this is important. So what are you tracking? You're basically tracking the number of rows that are written to a particular data set. So if you see a sudden change in an expected number of table rows, basically signals that too much data has been written. So if you use anomaly detection, you can see that the number of rows in a data set provided is a good way of checking that nothing suspicious is actually happening. I was talking to somebody again. I say this like I was talking to them yesterday, and I was, but I talk to people about this a lot, which is like they'll ask questions about, can you see spikes in the data set? Like, so if we were expecting, in this example here, we have an anomaly range. Basically, records go from 13,000 to 42,000. and we say that's an acceptable range. That may be too big of a range. I'm not sure in this particular example. Maybe it's like 13 to 14. Well, what we want to be able to do is set anomaly detection that goes out of that range. So if it hits 12 or 14, we want to say, hey, alert me right away. Because what could happen is in this particular row count or record count, rather, say that you're expecting that range between 13 or 12 or 13,000, or here it's 13 to 42,000, and all of a sudden it goes to 80,000, or all of a sudden it goes to 2,000. That's not an example. And if it goes to 0, that's a null alert. So you say, oh, we didn't even send data. But here we're saying we sent way less data than we were actually planning on having. This is an example of being able to do that, with being able to look at the record count within a particular run of your pipeline. We got 2 more here, and then I'll open up for questions here. So, okay. So tasks read by a data set. So we talked about writing, and now we're talking about reading. So the more tasks you read from a certain data set, again, the more central it is for the more important for this data set. So being understand the importance of that data set is very important for impact analysis, and realizing that how fast you should deal with the issue that you actually have. So this is an example graph here. It's basically showing the reads and writes, but it's also showing up at the top there, you're seeing the read. Down below, there are no reads. There's some writtens down here. This is just basically showing you, we can give you views into how this data set is performing over time and trend analysis. So you can understand, hey, this is a critical data set that is reading and writing a lot, and I want to make sure that nothing goes wrong there. So again, a lot of times I think data engineers and data platform teams, they'll have pipelines that they know are critical, but they may not know if a data set is critical or not. So these are really important to understand, not just from the pipeline level, but also the data set level, to bring you into that. And then the last one is around data freshness. So you can track the number of scheduled pipelines, the write to a certain data set. Again, if you're expecting it to come at a certain time of day and it's not there, you can basically put an alert in to say, hey, we missed this, or we didn't have something actually come up on the day that we were planning on it. So again, when the data isn't updated as expected, it can be wrongly fed downstream to these different reports. And the result, obviously, is consuming this wrong information, wrong data. So this is a good way of knowing your data's freshness. If your data freshness is good to go, is to monitor that SLA and be notified of any delays in your pipeline that should be written to that data set. So with that, I'm going to wrap up again with just kind of saying, hey, you want to be able to make sure that if you have any questions around data observability, it is an emerging category. It's an emerging space. That's why Eckerson Group has done this great event, at least this day event that I've been a part of so far. It's been really awesome. And I think right now is just bringing your teams more aware of the problems that observability is solving. And what solutions are out there, what products are out there, how people are talking about the space. So again, go to the demo center on Databand.ai if you just want to look at product videos. Go to the solution compare that Eckerson Group put together. Some great products out there. Obviously, Databand's a part of that. And if you have any questions, go ahead and do a request demo, and we're happy to jump in and really get into it. So let's get to some of the questions. So if you have questions, go ahead and drop them in here. And again, I'm not gonna, we have only about 5 or so minutes left. So looking at some of the questions here, one of the questions I had, or that we have here, is that there's data observability. Data observability is an excellent approach to solve network alerts and alarm issues. I don't know if that was a question or not. You can definitely do that if you're integrating to data pipelines that are going to data pipelines that are a part of these telecommunication companies or things like that. Definitely is a great way to alert around your data issues, specifically for data engineers. And I talked about this earlier, which is like the software space has been very, very, I guess, spoiled. If you're a software engineer and you're pioneering things like CI/CD and DevOps and microservices and all these things, you have these amazing tools that are out there. But the problem is, like, these data engineers, because a lot of them, all these software engineers are basically becoming data engineers. That actually doesn't allow them to actually be alerted on issues if they're pushing them over into their data team. So, okay, let me go to some other questions here. How can you create leading indicators for pipeline duration so that you know runtimes are trending in bad direction? Not problem yet, but future trends. So to that, Jay, I would say that's where it gets into anomaly detection. So that's what I always tell people too. It's like what you can do, especially with our product. What you can do is this: is that if you had, let's say you ran your pipeline like 50 times, and the last 10 times you actually cleaned up the pipeline, made it better. Maybe those 40 times was really bad, but you had a really good, those last 10, your engineering team got together and fixed it and it was all good to go, right? What you can do is you can basically do look back parameters when you're setting up anomaly detection to get to maybe a future trend. So let's say that what you really want to be able to alert it on is deviation from those last 10 and not those last 50, because there could have been some weird durations that were going on then. You can set that and say, hey, only look at my last 10 durations, set a baseline, and then we'll monitor against that baseline. And if it deviates outside of that baseline, we'll tell you right away. And that will give you an indicator of how a pipeline could be impacted in the future. This question around, in a scenario where data is captured from multiple sources, like hundreds to thousands, does the issue with those many data sets will trigger hundreds, thousands, or if this will cause chaos in the mailbox? Yeah, so that there's ways to set up the alerts to where it's only going to route to a certain area, and it's only going to route to a certain team or a core team, and it won't alert based off of, it won't send 1,000 different alerts if that were to occur. So the way you can set that up is you can route it to different teams. You can route it to based off of, hey, I only want it to fire the first time this happens during the day. If there's multiples that going on, only send it to that one person. So there are ways to manage the chaos from that with some triaging methods that we have within our tool. Julian asked, how do you map SLAs with data governance metrics? So there was a Gartner conference recently. One of the things that they were talking about is how observability is becoming more and more in addition to a data governance strategy. So data governance, obviously, we want to know, we want to make sure that we don't give access to certain data to certain groups and things like that. But it's also has a lot of things around data quality, especially also data cataloging also has a data quality subcomponents of that within there as well. And the way observability, I think, is kind of coming into both of these areas is being able to be a layer on top of your data governance metrics or even your catalog metrics, to where we're alerting issues around potential problems within those practices before they actually corrupt in those certain areas. And so right now, I think that observability is really focused on the data SLAs for the engineering team. But what it could also be used for is an alerting engine for meeting other groups' SLAs as well, like governance and also like cataloging and things like that. So hopefully that answers your question. I'm not sure if I answered it correctly, but I'll definitely reach out to you. Question around, I'll follow up with you, Julian, on the side. This question around, how do we go from customer voice to data SLAs? I'm not sure exactly understand what you mean by customer voice, but let me follow up with you after this session, because I know we're right over time. But everyone, thank you for joining. Really appreciate it. I'm happy to have any follow-up questions, and we'll be reaching out to people post this event. Thank you for joining. Go to Databand.ai to learn more. You can connect with me on LinkedIn. I'm just Ryan Yackel. I'm probably the only Ryan Yackel out there. Happy to talk to you. And then also, if you want to be on our podcast, love to have new people on the podcast if you're interested in lending your expertise to the data space. So let me know if you want to be one of our guests. Thank you for joining, and I will hopefully see you soon.